In this entire series of lectures, I'm going to take three plans and I'm going to explain you how to understand the plan. So this will be the first plan where I'll be explaining you. It's a ground floor plan what I have. I'll be explaining you the complete plan. Then we'll try to see the first floor plan. We'll see the section for that. We'll see how the site layout looks. We'll also try to understand what is the schedule of openings, like the door sizes, the window sizes. We'll also see the elevation, like this is the front elevation, the right elevation, and the section, and all these things. Going to cover in the first lecture, and after that we'll be taking up another plan. So this is one more plan. Okay, so in this plan we'll try to see how this particular plan is worked out. We'll understand how it has been put up. Then we'll also try to understand this the section part for this, how the section looks, how the front elevation look. And after that I'll be taking one a big bungalow plan. So this is a bungalow plan what I have, and for this bungalow I'll be explaining you how this particular bungalow has been worked out, where the column, where the kitchen, where the bedrooms are been kept, and how it has been particularly planned. So we have this for, it's a ground floor, then we have this for first floor, and then this is the second floor plan. And we'll try to understand the sizes, the lift, the staircase part, and also the terrace part. So once this is done, we'll be moving directly to one more plan. So this is the one more plan what we have. Okay. For this entire plan, we'll be seeing how this plan has been worked out. And for this, we are going to see the footing drawings. That is, we are seeing right now, whatever I explained, it is a from architectural point of view. We'll see how the structural elements are designed, like what is the size of a footing, the column layout, the plinth beam layout, the plinth beam reinforcement, the slab details, I mean the slab layout, the slab details, the staircase part, and all. So you can see it here. This is a plan. And then we'll see the footing layout. This is how the footing has to be worked out. And this is a column layout. These are the different sizes of the column and the reinforcement part. We'll be delting all these things in a more better way. This is a plinth beam layout, what I have. Then this is a ground floor beam shuttering details. Then we'll see all the reinforcement details. We'll try to understand how this drawings has to be understood. And also this is my ground beam shuttering details. And also this is my beam details. Then all these are my slab details. This entire thing is my slab details. And finally, we'll see the staircase part, how the staircase has been worked out. So this is my staircase part, so that we get an idea how the staircase looks and all. And finally, once everything is done, I'll be explaining about the Vastu. So we'll see what is Vastu, how according to Vastu you have to plan your structure, where the bedroom should come, where the kitchen should come, what is the basic principle behind the Vastu, right? Why is that we need to take care of Vastu? What are the different directions we have? And I've given you a small tip so that whenever you try to plan any of a building, you get an idea where a kitchen should be kept, where a bathroom should be kept, where the master bedroom should be kept. So this is the entire series. I mean, all these things are covered in my lecture. And from next lecture onwards, we are going to break down all these things in a lecture by lecture, and we'll try to understand. So you can see all these plans which has been put up here, right? So all these are the architectural plan. Before we start with any construction work, we are supposed to give a plan, right? Like let us say you want to do a home construction. So, and let us say you're doing a 3 BHK home. 3 BHK stand for 3 bedroom, B stand for bathroom, and H stand for hall, right? So you need to know where exactly is your bathroom, where exactly is your kitchen, what is the dimension of your rooms, right? So we give a AutoCAD plan to that, which we call it as an architectural plan. So we'll start with this now. We have a proposed ground floor, then we have a first floor. So it's a G+1. We have a ground floor and you have a first floor. Then they are going to give you the entire section, and this is the entire plot where you have and where the construction should happen. And these are your front elevation, the right side elevation, the left side elevation, and all other activities, right? So we'll start with this now. Okay. So before that, whenever you give any drawings, no, you're supposed to mention all these things, like what is the size of your door, what is the size of your windows, and all. So right now I'll get into this part. First I'll explain you about the plot, and then I'll come to this part, right? Yeah. So now this is my entire plot. If you see it here, yeah, so this is my entire plot what I have. Yeah, this is the entire site what I have. Okay, this is a site what I have. And then what is the dimension of the site? It is given here, which is 9.14, and this comes out to be 12.19. Okay, and now this is a site number. It is given by the government. Like if this is your site, we are giving a survey number to that. So it's written site number 31. And now they have planned in this much area, we are going to do the construction. Okay. Whenever we do the construction, it's not that the complete a plot we are going to do the construction. We are going to leave certain setback distance so that you can have a proper movement of your vehicle, or maybe you can do a proper movement around your house. Okay. So that is why we have done a construction here. And this space, this and this is a setback distance what I have. Now you see this is a proposed construction of ground floor and first floor in the site number 32. And here you are going to do the parking of a vehicle, right? This much is understood. Chalo. Yeah. So this particular thing is site number 31. This is site number 21. This is site number 33. And where you are going to do the construction, that is your site number 32. Okay. Chalo. Now here what is written, you are going to get everything here, like what is the proposed ground floor, what is the proposed first floor, what is the total built up area, that is how much built up area you're going to do. And then all these things are the certain uh, requirement by the municipality department and all those things. Okay. So the total area what we have in the ground floor is 74.03 square meter, and your proposed first floor is also 74.03 meter. If you add together, you are going to get 148.06 square meter is the total area. If you want to put this in square feet, it's very simple. We know that 1 square meter equal to 10.73 square feet. It's very simple calculation we are going to do. Square feet. Now what is the square meter we have got? It is, yeah, square meter. Yeah. How much we have got? 148.06 square meter. So if I want to put this in square feet, what I'm supposed to do? 148.06 into 10.76. Try to do it manually so that we can convert this into square feet. So 148.06 into 10.76. So it comes out to be 1593.12 square feet. So this is the total built up area what we have, including your ground floor and the first floor. Got it? Chalo. Fine. So with this understanding, we'll move forward. And then here they have written like all the dimensions are in meter. For this particular building, all the dimensions are in meter. That is good. And then here they are going to tell like who is where the building is being constructed, in which area and all. So it's written proposed construction of ground and first floor residential building in site number 32 and survey number 4, khata number. It's a government department what they give, and it is given here to whom it belongs and in which place. Okay. So these are the basic requirement whenever you do any planning. And then you're supposed to mention this thing, that is the schedule of opening, like what is the size of your door, what is the size of your windows and all. Okay. So it's written here doors. MD stand for main door. The entrance door what you put at your home, it's called as main door, which is 1 meter by 2.10. This is 1 meter and the height is 2.10 meter. D is another name what they have given, which is 0.90 by 2.10. D1 is another name what they have given, which is 0.75 into 2.10. And then the ventilator part and the windows they have given it here. Okay. This much is clear. Chalo. Now we'll get into the ground floor now. Yeah. So this is a proposed ground floor what I have. And now from here you are going doing an entrance. Like you will enter here. It's a 2 number of scooter parking. You can two scooter can be parked in this way. Okay. And then you're going to make a entrance from here. What is MD? MD is a main door. So you'll come from here. You have a small veranda portion here, which is 1.40 by 2.77. Always remember the first digit stand for the horizontal distance and the second is for the vertical distance. Okay. And then you come here. It's an opening. Opening in the sense you don't have any door here. D in the sense D, wherever they have written D, it means there is a door. MD stand for main door and O stand for opening. Opening in the sense you don't have any door, it remains open. Okay. That is why it is written O. And what is the distance of this? What is the distance from here to here? From here to here. So that we need to refer here. So it is mentioned here. If I go back, it is written openings O, which is 1.20 by 2.10. Got it? So that is what you mean by this O here. Yeah. So this is O. Okay. So once you come from the veranda portion, you are into the living hall. So this is your living hall. And then you have this up in the sense you're going up from, this is a staircase what you have. And from the living, again, you have this opening here. You don't have any door. We're entering into a kitchen. And your size of a kitchen is 3.45 meter by 2.41. And then you are entering into the bedroom, which is D. There is a door D here. and the dimension is mentioned over there. And this is your bathroom. G stands for general bathroom. General bathroom in the sense it's a common bathroom. Anyone can use it. It is not attached to any bedroom. So we call it as a common bathroom or a general bathroom. And they have a door here, that is D1. And then you come from here, you have another bedroom here. So this is a bedroom which is 3.31 by 2.77. And from here you have an attached bathroom. A bathroom in the sense attached bathroom. So this particular bathroom is attached to this bedroom. So hence it is called as attached bathroom. And the size is 1.60 by 1.50. And you have a door here, D1. Now, one thing we need to understand, always your main door will be of a bigger size, followed by your room doors, followed by your bathroom doors. What I'm trying to tell, this is a main door. Of course, the width will be more. Now coming to this door, it's a bedroom door. I have a bedroom here. I'm making an entrance through this door. So this door width will be larger. Okay. In comparison to the main door, it will be smaller. And in comparison to this D1 stand for your bathroom door. Again, you can see here D1 stand for your bathroom door. Again, the bathroom door width will be less in comparison to your room doors. Okay. So to put it in a better way, we'll come here quickly. See it here. Your MD is 1 meter. Your D is how much? 0.90 meter. And your D1 is 0.75. So that is the typical trend what we follow when we plan any building. Because if you're entering into a bathroom, only one person will enter, right? It's not that 2-3 people are coming at once. But if it is a your bedroom and all, there may be chances 2 people may enter at one same time, or maybe you require a little larger space to move, to make your furniture movements and all. So that is why we increase the breadth of your door for the bathroom, for the bedroom, and for the bathroom it's a small distance. So you can clearly see it here. D1 is 0.75 and D is 0.90. Whereas the height remains the same. Height we are going to keep it same for main door, for the bedroom, and also for the bathroom. So you can see 2.10, 2.10, and 2.10. Okay. Yeah, great. So I think most of the things I've covered it here. Along with that, this is window. You have a staircase here, but beneath the staircase you have this window. Okay. Similarly, you have a kitchen here, and you have put a window here. KW stands for kitchen window. Similarly, you have a bedroom here. You have put a window here, and this is W. That is a window. Again, in the same way, here you have a bedroom. You have put a window here, and the name is W. What is the size of a window? You have to come back here, and it is mentioned here. W stands for window, which is 1.80 by 1.35. And wherever W1 is written, it is 1.20 by 1.35. So I think everywhere it is W. Maybe in one place it is W1. So we'll search where exactly that W1 is written. Okay, kitchen window. Okay, everywhere it is a window there. No issues with that. Okay, W. This is main door, window, and all. And then you can see here in the bathroom portion, you don't give a window. We put a ventilator, right? If we are not putting a window in the bathroom, we are going to put a ventilator. It's a small opening what we provide. You can see it here, ventilator and ventilator. And then what is the size of a ventilator? It is mentioned here. Your ventilator will be 0.75 by 0.6. This is a typical size what we try to give. Got it? So I hope you have understood the concept up to here. We have understood about the ground floor. So now we'll try to get into the first floor part. Okay. So once you see, right now you were in the ground floor, right? Once you want to come to the first floor, you're going to take a staircase from here. Then you'll come here. Then you're going to come here. So this part you're going to reach here. Okay. So once you come, you're going to reach in this part. So here they are given a kind of a lounge so that you can sit here and you can relax. You can have your sofa sets here and you can relax here. And then whatever kitchen you had in the ground floor, they converted that kitchen into a bedroom. Okay. So again, you can see a bedroom here, which is 3.45 by 3.12 meter. And then you have a door here and another bedroom they have. Whatever bedroom you had in the ground floor, the same has been converted into another bedroom in the first floor. Now the bathroom, always remember the bathroom and all we never change. Whatever is there in the ground floor, usually we try to take it to the first floor only. Okay. So you had a general bathroom here, you had an attached bathroom. The same thing you can see it here, general bathroom and your attached bathroom. And then this entire thing, like you had a scooter or a parking here, right? So there was nothing there. Like in the first floor, we utilized that area and we have converted that into a balcony. Like you come from here, this is a lounge area what you have. Yeah, they have put a door here and you can come to the balcony. So this much portion, whatever you had here, which was being utilized for the parking, that has been converted into a balcony in the first floor. And then this veranda and the bedroom portion has been turned down or has been converted into a guest room. So it's a very big room what you have for the guest. Okay, so it's a very good planning what they have done. If you are a family of 2 or 3, I mean, if you are two, how do I say that? Yeah, if there are 2 different families staying or 3 different families staying, then this is a good plan what you can have. You have enough bedroom in the ground for 1 and 2 bedroom, and in the top you have another 2 bedroom, which is 4 bedroom, and then a big bedroom for a guest. So it's a very good planning what they have done. And you have good number of toilets also. You have one general toilet where this bedroom and this bedroom people can utilize that, and then there is one more bathroom here, which is an attached one. Okay, so very good planning they have done. Now we'll come to the elevation part. Elevation in the sense how your building is going to look from the front side, from the right side and all. So this is a front elevation what we have. Okay, so this is your ground floor and this is your first floor, and this is your parapet wall. Parapet in the sense whenever you do the construction on the top floor, you don't leave it. You just put a small wall of, let us say, 1 meter, so that it will act like a um, barrier, so that no one gets down from there. Okay, no one falls down. So this is a parapet wall what you can see. It's a cantilever. What this is all, this is a 𝗬𝗃𝗃. Okay, this is your window here. You have another window here. This is your balcony portion. Now you see here, this is a front elevation. Okay, so in the front elevation, if you observe the balcony, whatever you see it here from the front, it looks like this. You have a door here, and what is this door here? This is that door D. Can you see the D here? This is that door, and this is a balcony portion what you have. And this is your window which is here. So this particular window is this window. Okay, this particular window, because it's a best guest bedroom, right? And this is a window what we have. And this is your front elevation. Okay, this is your front elevation. This window whatever you can see, it's this window, this particular window, and this particular portion is your this particular portion. Got it? So it's a front elevation. Now we'll see the right side elevation. So how will my right side elevation look? So if this is my, what is my right side? So this is my right side. Agree with me? This is my right side. So in this way, your right side elevation will look. Okay. Yeah. So again, this is how you are right. Again, it's the parapet wall here. This is your first floor. This is your ground floor. Again, you have 1, 2, 3, 4 windows here, and you have a door from here. It's a main door. What you get? Okay. Yeah. Next, coming to the section part. Again, we have this rear side elevation from the back side. How your building is going to look, and this is your left side elevation. Okay. Great. So in this way, you are supposed to do the elevations also, so that the client will get an idea how his building is going to look. Now coming to the section part. So in the section, you're going to get like how much is the depth of excavation you're supposed to do, what is your floor to floor height and all. Okay, so we'll start with this now. So this is a CC bed. CC bed stands for cement concrete bed. I'll repeat it again. CC stands for cement concrete bed. Usually we call it as a PCC, which is called as plain cement concrete. And after that, we are going to do the masonry work. Okay, stone masonry work. Like soon after that, we are going to construct with the help of a laterite stone in the local construction. What we do is we make use of stones, and we construct that up to the ground level. Okay, and then after that, we are going to put the plinth beam. So this is RCC for the plinth. So you have a RCC here. You're going to put the RCC for the plinth beam, and then we are going to come with the ground floor. So this is my ground floor. What is my floor to floor height? What is the distance between my ground floor to the roof of my first floor? It will be usually 3 meter, but here you can see it here. So it is given from here to the here to here. It is 3 meter, and this will be your slab thickness. This is your first floor slab. Usually it will be 150 mm, or let us say it is 6 inches. Okay, so now floor to floor height is my 3 meter. Okay, then you can see it here. You have a RCC lintel here, and then you are going to get a RCC roof here. Okay, and then again this is my first floor. Again the floor to floor height is 3 meter. So again they have put it here. Again this is the RCC roof, and over that what will happen? The parapet wall is going to come. So this is my parapet wall, which they have mentioned it here. You got an idea? The total height of your building from the ground level to the top of your roof is 6.90 meter. That is 3 meter plus 3 meter, and then this much height whatever you have, no, you're supposed to add it, which comes out to be around 0.9 meter, which is 900 mm. That is what they have added it here. Okay, so you got an idea how your entire structure is going to look. And then this is a section. Yeah, this is another section what they have cut, where they're showing you the staircase part. So your staircase will start from here. Then this is your landing areas. Okay, these are your steps, and then this is your flight. This is your flight number 1, and here you're going to take your flight number 2. This is your landing area, and this is your flight number 3, because your staircase is in this shape. You're going to come here. This is a landing area. Then again, you're going to come to the top. Okay. Then this is landing area, and then you're going to reach to the first floor. Got it? So I think most of the things I've covered it here. And this is your details of the rainwater harvesting structures. Okay. So this is typical people try to do, because now government is making it more mandatory to conserve the water. We don't want the rainwater to just flow away. So what we do, we try to make a lot of rainwater harvesting pit, so that the water gets collected and the groundwater is going to increase, and the water table is going to increase, so that we don't have a scarcity of water. So that is why this is a typical I mean section of a percolation pit what they are given. So in this way you are supposed to do nothing. You just have to do the excavation. The total excavation depth will be given here. It is 3.83, roughly 10 feet of excavation you are supposed to do. And then this is a borewell what we are going to dug. Okay, this is a borewell what we are going to dug here. And then all these things are a 40 stone aggregate you are going to put. Then it's a 20 stone aggregate. Then you are going to put a coarse sand, then the fine sand, and this. So why it is in this way? Because it has to, your water has to percolate through that. Okay, your water has to percolate in this way. That is why we are going to put a fine sand, then the coarser sand, then the 20 stone aggregate, then the 40 stone aggregate, so that if any dust and all is there, it remains here only, it will not go to the bottom. Okay, so this is how a typical rainwater harvesting structure looks. Okay, so you have a 40 aggregate here, 20 here, you have a coarse sand, you have a fine sand, and this is an empty space of around 0.10 meter depth. Okay, so this was all about the, yeah, so this was all about the plan we had taken for this building. Similarly, yeah, I'll be showing you this in the color one. Okay, yeah, so this is a different building what we have. So here the plan is again different. No issues. We'll take up this in the next lecture. So we are done with this particular building, and I hope you have understood like how the plan has to be understood. What is the section? What is the elevations, and how the other front elevation, the side elevation looks. So in the next lecture, I'll be either taking up this particular drawing, so that we'll get an idea how this particular thing is worked out. Else we'll be taking up another 2-3 drawings, so that we get an idea. So we'll be taking up this particular plan, and we'll see how this plan is different from our previous plan. Okay. Again, everything remains the same. You can see it here. Again, they are mentioned who is the owner of this particular building, and they are given the calculation like what is the site area, what is the proposed ground floor area, what is your proposed first floor area, and what is the total area. It's again 273.19 square meter. Quickly try to do the calculation and tell me how much this comes out to be in square feet. Okay, square feet. So we know that. I'll quickly do it. You also can do it along with me, so that you get an idea. So it comes out to be 2,939 square feet. Just multiply this value by 10.76. You get it in square feet. Okay. Along with that, they have mentioned it here, the schedule of openings. Like, see, this time you see there are a lot of windows and doors. You have a MD for main door, D is for the normal door, PD stand for the puja room door. You have a puja room. In the typical Hindu culture, we have a puja room in our home. So PD stand for the puja door. Then we have D1, O is for the opening, O1 is for another opening, and WW1 is stand for the window. KW stand for the kitchen window. And coming to the ventilators, we have V and V1. Okay, great. Now we'll start with this particular thing. So this is a proposed construction of ground floor and first floor. So this is a typical site what they have of this shape, and they are going to do a construction here. Okay, great. Now we'll get into the ground floor plan. So right now, this is my ground floor plan. So this is a portico portion. That means portico is a small cantilever slab what you're going to put, where you can make your vehicles park there. Okay, and it's a very good place which looks good. I mean, that is where the main look for your building is going to come. So you're making an entrance from here. Okay, you can park your vehicle here, your car here, your scooter here, and now here comes the MD. It's a main door. You have a veranda here. So O1 stand for the opening. Again, you don't have a door here. You have a main door, right? Soon after that, you don't have a door here. They are given O1. And then you have a very big, living hall, which is almost 5.37 by 5.18 meter. And from there again you come to this portion, you have a opening here. So it's a dining area where you can sit and have your lunch. So 2.90 by 2.90, and from here itself you have an opening to the kitchen, which is again 3.96 by 2.90. And they have made a storeroom here so that you can store your groceries items, and all those things can be stored here in the store portion. Okay, so that your kitchen will look neat and tidy. Okay, then you come here in the living hall. They have done this puja room. It's a puja room, and PD is a puja room door here. Then after that, we'll come to the staircase a bit later. And then you come here, you have another opening. Then here you enter, you have a bedroom number 2. Anyhow, we'll come here. You came from here. After coming here, you have this opening. You have a bedroom number 1 here. Okay. And then you're going to keep your wardrobe in this way, and you have a door in this way. And this is a attached toilet what they have. Okay. Which is 2.56 by 1.55 meter. And you have a door here. Now coming out from here, I'll go to this bedroom number 2. I'm going to keep my wardrobe in this portion, and I have a door here. And then there is a small passage which will take you to the backside of your home, where you have a utility. Utility is basically a place where you can where you can wash your clothes, you store your washing machines and all. So that is a place where why it is called as utility. And then you have a water closet here. Okay, and then you have a general bathroom. That means in the entire home, you have one attached bathroom here. Okay, and then this particular portion you have a general bathroom here and a water closet here. Okay, and then of course you have a staircase from here. You're going to take a staircase from here, come here, and then you go to the first floor. You're getting my point? So I hope this much things are clear. Now we'll come to the this thing, that is the first floor. So once you've taken a staircase, you have come to this part, you are landed here. So from here, if you enter here, you have a bedroom number 4. Okay, I think, yeah, let me not go into the bedroom number 4. I'll go to the bedroom number 3 and come to the 4. Okay, I landed here, I went here, I have a door here. Again, I have a bedroom number 3, and I've kept a wardrobe here. That means whatever is there in my ground floor, no, the same thing I've done it here. I have a general bathroom here. Here it was attached bathroom. Okay, but here they've converted that into a general bathroom. Okay, and then from here, if I come, I have a bedroom number 4. So this is my bedroom number 4. Again, I kept a wardrobe here. And now this much area, whatever you had in the ground floor, this much entire area, almost this much area. Okay, yeah, almost this much area, whatever you had in the ground floor, isn't it, that has been converted into open space here. Okay, and then this small portion what was left out, this small portion which was a utility in my ground floor, that has been converted into open space number 2. So a good planning they have done. They didn't want to put lot of bedrooms. They could have even converted this into a bedroom, isn't it? Instead of keeping an open space, this bedroom whatever 3 you are seeing, they could have converted that into, like, this would have been such a big bedroom. We could have done that. We could have converted this into a big bedroom, but they didn't want that to happen, and they could have converted this into a bedroom also. But still, the client maybe was not interested to do that. He was okay with a 4 bedroom, and then he has converted this into a big open space, so that whenever your friends come, or you have a party, you throw a party, you can enjoy in this particular space. So that was a main intention, I feel. So that has been converted into open space. Now again, once you reach here, right now we are here. Okay, so this is that particular portion. I'll draw a line over that. Yeah, this portion. Yeah. So again, the staircase remains same. Staircase we never change. Okay, it will go ground floor first floor. It remains the same. So this living hall was turned into a bedroom, and this much portion, whatever you had, like the store, the puja and all, that has been converted into a passage. Like this particular portion, this particular portion is converted into a passage area. It has been converted into a passage area, and then you don't have anything in this way. Okay, in this region you don't have anything. Only the thing is, what they have done is, this particular area, the kitchen, up to this much area, whatever they had, right, up to this area, whatever they had. Yeah, this much area. Okay, this was the entire area, but they haven't utilized the entire area. They might have used only this much area. So you can see only this much area they converted into a balcony portion. That's it. So it's a small area. Maybe up to here it's ending. I'll draw a line over there. So this is that line where it is ending. Okay, this is that line. Great. So only the thing is this is 1.1.5 meter. This is 1.5 meter, and the length is 4.41 meter, because it's a balcony, right? You cannot take a big cantilever part. So you have to understand the structural concept. You could have taken a cantilever something like this also. Okay, you could have done something like this also. But again, since it's a cantilever, like if so, I have a beam here. So this will be like a cantilever. So I have a beam here. Okay, this is your this particular area. This particular area is this one, and here I cannot take a cantilever of this length. What will happen if you put it? Will going to fall, because there is no back anchorage to that. So cantilever max to max you can go with 1.5 meter or 3 feet cantilever can be taken. Okay, that is why it is only 1.5 meter. So that is the reason you can see it is only up to here, because this is only this much cantilever I can take. Okay, I cannot take a cantilever like this. If you're taking a cantilever like this, then the depth of your cantilever, I mean the thickness of your slab will be huge. Okay, so that is why in order to reduce that thickness, we can only give this much cantilever, which is 1.50 meter, roughly comes out to be around 3.5 feet, and that's a good cantilever length. You can keep it. Great. So I hope your ground floor and the first floor concept is clear. And obviously, we'll come to the front elevation now. So this is how your front elevation looks. So can you tell me how the front elevation looks? See here. Yeah, we'll do in this way. So you can see I have a one window here. Okay, I'm standing here in front of that home. I can see this window. I can see this window, and I can see this door. So that is the reason you can see one door, one window, second window, and a door here. Okay. Other than that, this is my ground floor. Other than that, I cannot see anything. I can see in the first floor. So if you come to the first floor, so in the first floor, you can see this door here. You cannot see the balcony. Okay. You cannot see the balcony in this way, but you can see this door. So that is why they have drawn a door here. This is a door, and you can see this window also. So this is a window. But if you go to the top, I mean, if you go to the first floor top, you are going to put a parapet wall. So you can see a parapet wall here. So this is how a parapet wall is drawn. Got it? Chalo. Yeah. And this is a key map what they have put. Like this is a proposed site. This is somebody else's property. This is also somebody else's property. And they have a road what they are given. Like this road is going to Chennagiri. It's a place, and Biru is another place, and this is a bus stand what they have, and next to that they have a proposed site. Okay, yeah. So the front elevation is understood. Now come to the section. This section is very good here. So in the section you get each and every measurement, right? Like this is a ground level. Ground level is a normal level where you are going to start your construction. If you go out of your home, whatever ground level, whatever level you have, wherever you get a soil, that is your ground level. Okay, so this is my ground level. From there I'm supposed to do this much of excavation, that is 0.6 meter, and then another 10 mm 100 mm. So 0.70 meter of excavation has to be done, and then my plinth beam will be up to this level. This is my plinth, that is 0.90 plus 0.60. This is my plinth level. Okay, and this will be my plinth beam, this much portion. And now my floor level starts. So if this floor to this floor, it is 3 meter. From this floor to this floor, it is 3 meter. Now this lintel, whatever you are putting, so this is a window what you are put, and this is a lintel whatever you are put, because wherever we have window, over the window you can see a small sunshade or a cantilever portion. Okay, which will avoid the passage of water through a window, and it will also safeguard your window or your room from the excessive sunlight. So we put a sunshade. So this is that sunshade. At what height it has to be put from your ground level? It is 2.10 meter. And what should be the thickness of that sunshade? It is 0.15 meter or 150 mm. Then after that, again, it is the depth of your lintel will be 300 mm. So this is a not the lintel. This is a this thing. The brickwork what you're supposed to do, which is 0.30 meter. And then again, this is my first floor. In the first floor, from this floor level to the bottom of my lintel is again 2.10 meter. Then again, this remains the same. And what is the height of your parapet? It is mentioned here. The height of your parapet is 0.90 meter. Okay, got it? So these are the door and the other part. And then this is your width of your PCC. This is your PCC width, which is 0.90. And the thickness of your PCC is 0.10, which is 100 mm. And all these are your this thing. The stone work, the laterite masonry work you're supposed to do here. Okay. So this is a GL level. Got it? Yeah. And these are the foundations what you're supposed to do. For the foundation, you'll be getting a different structural drawing for the footing, for the column and all. That will take up in a live project where I'm going to explain you that. Yeah. So I hope, and then they have given a small solar system here. Maybe at the top they are going to keep a solar system. So they have drawn a solar system here, and this one they are going to install at the top of the parapet. Okay, great. So I hope, and then this is of course the typical rainwater harvesting pit. Again, it's the same thing what we understood in the previous lecture. You have a ground level, then you are going to put a borewell here, and these are the RCC rings, and this is a PCC, and those pipe you are going to put and all. Okay, so in this way all the drawings will be prepared, and based on that you are going to do the construction. By taking your ground plus two-story building, it's a big residential building. We'll try to see that. Okay, yeah. So again, it's a ground floor plan. Okay, and what is the total square feet it has? It is 2535 square feet. And can you convert this into square meter? Obviously you divide it by 10, you get it by you divide it by 10.73, you get this in square meter. Okay, chalo. So again, this is a road which is going by, and they have a car parking here. You can, so this is a porch area. Okay, you are making an entrance from here. So you have a porch area. You have one porch here, the second porch. Okay, so this is a gate what they have. Okay, and here they have one more road. They have one more road here, and they have one more road here, and you are making an entrance from here. Okay, you have a porch area, so you can do a two-car parking. It's a big bungalow what we have, and from here you are going to come to the veranda portion. So you have a steps here. This is step number 1, this is step number 2, and you have a veranda here. So once you enter into a veranda, this is your main door, and from the main door you enter here, and you have this circulation yeah, circulation lobby here. Okay, and from here you have an elevator. Since it's a ground plus two-story building, ground floor first and second, they have kept an elevator here so that people don't have to take the stairs, they can make use of the elevator. Okay, and this entire is a circulation area, and they have a staircase here. We provide both. If you want to take staircase, you can take staircase. If you want to use a lift, you can use that. Okay, and then you come here, you have this area here. It's a big living hall, which is again 13 feet by 22 feet 6 inch. So you have put all your sofa sets here, the table, the stool here, and you have put up your TV here. Okay, this is a TV unit, and then you enter here. You have a dining hall here. So it's almost 14 feet by 22 feet of a dining hall here, a huge dining hall. And from there, you come here. You have this bathroom and the other part. Like if you come here, you have your powder room. So powder room, and here you have a wash basin. Okay, this is a wash basin, and here you have a powder room. So powder room is basically where you cannot have a bath here. Just for using the toilet you can use it. So that is why we call it a powder room. Okay, and then after that, again circular. Once you enter here, you have one more bedroom here. So this is a typical bedroom what they have. They have a TV unit here. They kept two sofa set. You have a window here, and then to this you have this walk-in. Okay, to this you have a walk-in. I mean walk-in in the sense it's a kind of a storeroom where you can do a dresser, you can keep your wardrobes, you can keep your clothes here. And then from here itself you have an entrance to the toilet. This is an attached toilet. Okay, so you have a wash basin, you have a western toilet, and this entire is your toilet. Getting my point? So in the same way, so this is done. Yeah. So from the dining, you enter into this particular area where you have a kitchen. So this entire thing is a kitchen. You can see the sink here, and this is a fridge what they have kept. This is a gas stove what they have, and they have a store room here so that you can store the groceries items and all. And from here itself, you are going into the wash area, which you can call it as a utility. Okay. So from here, if I come out again, if I enter into this, this is my bedroom number 2. Again, so the typical bedroom. You have a bed, then you have a TV unit, you have a two sofa set here, and from here you are getting into the this thing, the dresser room, that is a walk-in, and from there you have an entrance to the toilet. Okay, so this is a typical floor plan of your bungalow. And then if I come out, so up to here all the things are done, and from here it's a kind of a sliding doors what they have put. Okay, you can take out the sliding door, you can come out. It's a patio what we call. So it's a kind of a place where you can sit and you can enjoy, you can spend time with your family. And this entire thing they have put up a lawn. Okay, so a kind of greenery, you can see everywhere it is a lawn here. And here they have put a kind of a table and all. Again, it's a kind of a gazebo. So you can sit here and you can enjoy your time. So this is the kind of a plan what we have, and it's a ground floor plan. So once the ground floor plan is done, we'll go to the first floor plan. So first floor is also 2570 square feet. So when you come to the top portion, this is a staircase what you have taken. Okay, we came up to here. Again, it's a circulation lobby here. You have a door here. It's a covered sit out here, and then you have a terrace garden here. Okay, and of course the elevator remains the same and the staircase remains the same. Then again, whatever bedroom you have, again they have converted this into a bedroom. This is a master bedroom what we have. Okay, and yeah, how do you enter into this bathroom? Yeah, so it's a master bedroom what they have, which is again a 17 feet by 15 feet master bedroom. And then it's a circulation area here. Then again, they have put a passage here. Okay. So passage, even this is also passage. So this means it's an opening. Whenever they put a cross mark, that means you don't have a slab here. From the top, from the first floor, you can see what is happening in the ground floor, this much area. Okay. So this entire living hall, you can see whatever living hall is here. This living hall, whatever you have, no, that can be seen from the first floor. So you can see the X mark here. That means there is no slab here. It's a cutout portion. Okay. Yeah. Then you have another bedroom here, which is bedroom number 5. Whatever bedroom you had in the bottom, I mean in the ground floor, the same bedroom is here. And then you have a walk-in, and then there is a toilet here. Okay. And here from the passage, you have a balcony here. So this balcony is in the first floor. And again, this is a way to your bedroom number 3. And from here, you are entering into this dresser, and from there to the toilet. And same is the case here. This is a master bedroom. From this bedroom, you are entering into the master this thing, and from here you are entering into the toilet. Okay, so I think they should have done an opening here. It's not visible, maybe in the drawing it's not shown. Okay, yeah, maybe this may be a opening where you can enter into the bedroom. Yeah, so this bedroom is done, and then this is bedroom number 4. So whatever your kitchen, the dining area we had in the ground floor, no, that has been converted into a bedroom. This is another bedroom. Again, same thing, walk in and then the toilet. Got it? So this is a typical second floor plan what we have. I mean the first floor plan. Now we'll go to the second floor plan. So in the second floor plan, again, you come here, you took a staircase, you come up to here. So it's a Mumty level, what we call. Again, the same balcony remains here. The elevator remains here. This entire area, whatever you had, right? They have converted that into a terrace portion. This entire is a terrace portion, and they have given one store and one water closet here. So here they can organize a big party and all, so that in the terrace they have a very good space, right? They have a very good area here, and they can organize the parties, and they can enjoy the time here. So it all depends on the client. Again, that's it. Okay, and there is nothing in your this portion, that is second floor. You're not putting up any bedrooms and all. So the entire portion is utilized as a terrace. You can see terrace written here. So it's a client requirement. Based on the client requirement, based on his lifestyle, we try to do such kind of plans. Now maybe here the client is having a lot of money, and he want to spend a lot of time with his families, and he want a lot of luxurious kind of stuff in his life. So that is why you can see each and every bedroom they have a bathroom, then they have a dresser, and then they have a separate space for the terrace garden. There's a covered sit out, and then in the roof portion, that is in the second floor, they have a balcony here, elevator, and then the big terrace portion. So even you can make use of this terrace portion, for playing activities, like if you're interested to play badminton, table tennis and all, you can put a table tennis uh, table here, and you can cover this area. So that may be the plan of the client. So based on that, whatever is the requirement, we have done a plan according to that. And then of course we have to give the locations, I mean the direction, which is a north, which is a south, which is a west, and which is a east direction. Got it? So I think and this is a typical I mean this is how the your building will look. I mean if you're putting a ground floor, this is a typical plan. This your plan looks something like this kind of shape we are going to get. So that is why they have drawn it here. Similarly, when you come to the first floor, it looks like this. I mean, this is the second floor. This is your ground floor. This is your ground floor. So this is how your ground floor looks. The same thing you can see here. It has been drawn here. Okay. So that is how the entire plan is worked out for this particular building. It's a ground plus 4, and it's a big bungalow, and everything has been planned, and everything is spacious. If you look into the room sizes and all, it's almost a 14 feet by 19 feet room. and even the bathroom is almost 7 feet by 7 feet. I mean 7 feet by 7 feet. The walk-in is also a 7 feet by 7 feet. So a good planning they have done based on the requirement. So I hope you have got the idea regarding how a planning has to be done based on the client requirement, and how to keep the certain dimensions. Now through this, what you can do, try to note down all the dimensions what I have told, so that whenever you want to do a plan, you can take the certain dimensions of a room. Like, see, of course this is a very big plan, but the earlier plan whatever I had taken, the bathroom, the bedroom sizes and all, they're the typical plan what we try to give. So you can do all those things, so that if you're tomorrow if you are supposed to give a plan to any of your client, you can take the same dimensions and you can plan keeping all these things in mind. I'll take this complete plan, and I'll be explaining you right from the architecture. We'll see the foundations plan and all other things in this. Okay. Yeah. So come to the ground floor again. Again, you can see it here. All the things has been given here. Like, what is the site area? It is 2,400 square feet. What is the ground floor area? It is 1435, and the total built up area is 1435. Okay, and only a ground floor they have put up here. And who has done, what is the proposed it's a proposed residential building, and who has designed that, who has drawn that, what is the date on which this particular drawing has been done. Each and everything will be mentioned, and of course the direction has to be mentioned, like this is north, south, east and west. And then the schedule of openings, like main door, the openings, the door, the ventilators and the window. So we'll start with this again. So you have a portico here, which is 10 feet by 12 feet. And from there you enter into a main door. You have a small veranda here. And from there you enter into a living room. So they have kept a TV unit here and a sofa set here and a table here. And from there it's an opening here. And from there you enter. So once you come here, we have a bedroom number 3 here. They have a dressing table, and these are the wardrobes what they have kept, and this is a bedroom 3. So there is no attached bathroom here. And from here, if you go out, then you come to this particular area. You have a dining table kept here. We have a puja room here. And then if you enter here, you have a kitchen in this portion. So this is a wash basin, I mean wash sink. Then the burner here. Okay. Yeah. So once this is done, you come out of that. Then you go to the bedroom number 3. So it's again a 10 feet by 12 feet 6-inch bedroom. Again, there is no attached bathroom to this. And then you come here, you go to this particular master. This is called as master bedroom. Okay. And you have an attached toilet here, which is again 8 feet by 5 feet. And from here you come out and you come here. So they have kept a washing machine here, and they have a water closet here and a bath here. Okay. So that means altogether there are 3 bedrooms. This should have been bedroom number 1, or this should have been bedroom number 2. What we can do is I'll change it. Let me make this as bedroom number 2. Okay. So if this is bedroom number 3, yeah. So this is bedroom number 1. I have given master bedroom. Okay. Then the bedroom number 2, and this is bedroom number 3. Done. So my ground floor is done. What is the total area of this? It's a 40 feet. This is 40 feet, and this comes out to be around 60 feet. Okay. This the length comes out to be 60 feet, and this is a 40 feet. So the total is 2,400 is a plot area what we have. Okay. 2,040 square feet. You can see the site area is 2,040. How? 40 into 60 is 2,400. It's a total square feet what we have. Out of that, we have utilized only 1435 square feet. So out of that, wherever your house is built, right? So only in this much part your house is built, this much part. So it is almost 1400 square feet we have utilized for that. Okay. And other things it is mentioned here. Now we'll go to the other part. Yeah. So it's only a ground floor plan we have. Yeah. Okay. So it's the same thing. I think there is no changes in this and this drawing. Only thing is they have given a different plan. That's it. So here, this is another plan. See, whenever you do a planning, right, we don't give a single plan. We try to play with the plan, right? We may make certain changes here and there. So that is why I feel this is another plan what they are giving, which is very similar to this plan. Only the thing is they had a bedroom here and there was no door here. But here they have given the bedroom and they have given a door here. Rest, I feel, rest all things remains the same. There's no changes in that. If you see it here, if I, yeah, so you have a bedroom, you have wardrobe in this. Yeah, almost everything is same. There's no changes in that. Only the changes, there was no door here, but from this bedroom they have given a door here. Okay, yeah. So good. So this was all about the plan of this particular building. So in the next lecture, I'll take you to the, yeah. So this is one more plan they have given. So this plan is also similar, no changes in that. Yeah. So this is also another. Okay, all the plan remains the same. I don't know why four plans has been made here, but no issues. The plan remains the same. Just understand, there's only one. Let us consider this is my final plan. Okay, so this is my final plan, and the client has said okay, we can go with this plan. So once the client says okay, we can go with this plan, what we do, we try to give the structural drawing. So far it was my architectural drawing. Now we need to decide what is the length, breadth, and depth of your footing, what is the size of your column, what is the size of your beams, the size, the thickness of your slabs and all, which we are entering into a structural field. Okay, so here the role of architecture will end only here. He has no role in the structural drawings. These are my structural drawings. We'll try to understand. So the role of architecture will be more of preparing a plan like this. And when it comes to the interior part, okay, so then again the role of architecture comes into play, right? So in the next lecture onwards, I'll be explaining you all these structural drawings so that we get a basic idea how the structural drawings are to be and how we are supposed to understand. So we'll see into the footing details now. So this is the first drawing that you're supposed to see. Okay, it's the footing details what we have. Even before the footing details, we have to start with the column layout. But no issues. We'll start with the footing details now. Okay, sure. Yeah. So whenever you start your construction work, you're supposed to look into this part. Okay. So this part will tell you like what is the grade of a concrete you're supposed to use, what is the grade of a rebar you're supposed to use, and what is the minimum depth of excavation, what are different clear covers you're supposed to use. So quickly we'll get into that. So these are the basic point what they write. That is, do not scale the drawing, follow the written dimensions only. Read this drawing along with the relevant architectural drawing. This is very important. The structure is designed for a ground plus 2 upper floor only and for live load and dead load only. That means this particular structure has been designed only for a ground plus 2 story. That is ground floor, first floor and the second floor. Okay. And we cannot put another floor over that. So that is strictly what they have written it here. And it is only designed for live and dead load. Dead load in the sense the self weight of the beam, the column and all. And the live load is like once we get into that house, we all are live load, we the furnitures and all. So along with that, we'll be having a earthquake load, we'll be having a wind load and all. For that, in this particular building is not designed. Excavation depth is 5 feet minimum. That means minimum 5 feet of excavation has to be done whenever you're putting your footing, and foundation to be laid on the firm soil. That means very hard soil. Whenever you get there, you're supposed to put your foundation, and you're supposed to make use of M20 grade of concrete, where M stand for mix and 20 is the characteristic compressive strength of the concrete. Got it? Yeah. Now the grade of a rebar, because since we are using RCC, it's a combination of a concrete and the rebar. So the rebar what you're supposed to use, it belongs to FE 500, where FE stands for iron and 500 is the yield stress of that particular rebar. Okay. Other than that, these are the cover what we are supposed to give. That is for the slab, it is half inches, which comes out to be half inch comes out to be uh, around 12.5, right? Yeah. And then for the column, it is 1.5 inch. And for the footing, it is 2 inches. 2 inches comes out to be 50 mm. So I'll put it in terms of mm. So it is easy for us. Footing, it is 50 mm for us. Okay. Column is 40 mm. And for the slab, it is usually 20 mm. Okay. Even though they have mentioned it half inches, it's okay. It is 20 mm. Okay. Next is safe bearing capacity of the soil is 180 kilonewton per square meter. And the lap length, it is 47 times the diameter of a bar. And rest things are okay. The footing, wherever you're putting the PCC, it has to be 100 thickness of a PCC, that is for the plain cement concrete, and the ratio is 1 is to 4 is to 8, right? So this is a basic explanation what they try to give. Yeah. So now we'll get into the footing drawing. So this is my footing drawing. So we'll start from this. So again, this A, B, C, D, E, F, all these are the grid lines. In the same way, these are for the vertical grid lines. 1, 2, 3, 4. In the same way, in the horizontal, we have again 1, 2, 3, 4. This is 5, and this is 6. Okay. So in this way, the grid lines will be prepared in the AutoCAD software, and then we are going to give the footing. Now we have one footing here. Can you identify this footing? So just quickly tell me what is the name of this particular footing. So this is a footing what I have. Okay. and the name of the footing is mentioned here. So what is the name of a footing? It is F1. The name they have given is F1, and over this footing we have C1 column, right? So this much you are in a position to understand what is the size of my footing. It is mentioned here. So this size is actually 4 feet 6 inch. So this is 4 feet 6 inch, and this is also 4 feet 6 inch. This is also 4 feet 6 inch. Got it? So the size of my footing is 4 feet 6 inch and 4 feet 6 inch and 4 feet 6 inch. Here you are not going to get the depth of your footing. For that there is a separate drawing which is called a schedule of drawing. In that it will be mentioned. Right now we are seeing the plan from the top how it looks. Okay. Now come to this part. Again, what is the name of this footing? The name of the footing is F2, and the column coming on that is C2. So again the size of the footing is 5 feet, and this side also it is 5 feet. Okay. So two are done. Now we'll go to the next footing. The next footing is my F3 footing. Again, it is a 5 feet 3 inch by 5 feet 3 inch. So next, again, I have one more footing which is F1, which is again 4 feet 6 inch by 4 feet 6 inch. So in this way, all the footings, the dimensions and all will be given here. Then F4, F5, F5. Then they are given a name as F48, F4A. Then it is F2 footing. Then it is F5 footing. Then it is F6. Then again it is F4A, then again F6, F28. So quickly tell me what is this footing. Of course, the name of the footing is F4, and the size is 5 feet 11 inch by 5 feet 11 inch. Exactly. So in this way, you are supposed to understand this. Okay. I hope by this time you have got an idea like how this particular thing looks. Anyhow, I'll show you this through a practical image. And now coming to this part, whatever we have studied here, right? Like F1, F2, F3. If it is difficult for you to understand it from here, they give a table similar to this. Something like this. So again, they have mentioned the footing numbers as F1, F2, F2A, F3, F4, F4A, F5, F6, F7, and F7A. And the footing type is it's a pad footing. It's an isolated footing. Now coming to the dimensions, you can see the length, the breadth, and the depth is given. So this depth you don't get here. Okay. For example, if I consider F6 footing, what is the size? It is 7 feet by 7 feet. Agree with me? Come here, come to the F6 footing. So this is my F6 footing. Okay, this is my F6 footing. So what is mentioned here? 7 feet by 7 feet. But this 22 inches, you don't get it here. It will be written in the cross section part. So that is why they have made a separate table for this and they are given it here. Okay. So now to put it in a better way, let me quickly show you one of the drawing, one of the practical image for this so that you get an idea. Okay, it's not possible, no issues. So just remember, I'm explaining you what is F6 footing, 7 feet, 7 feet by 22 inches. So that means practically this will be a 7 feet. So if this is a footing, okay, so this will be a 7 feet. Okay, I'll directly take you the footing only. Before we do the concreting work, we do a shuttering work, something like this. So this will be 7 feet from this outer to this outer. Again, from this outer to this outer, it is 7 feet. And the depth, whatever you saw, right? It was 22 inches. Agree with me? So this will be 22 inches. This particular depth, whatever you saw, it will be 22 inches. Got it? So in this way, practically on the site, all these things will be done. For example, I'll show you the complete footing now. So once it has been concreted, yeah. So if you understand it, yeah, we'll try to understand in this way. So this is my 7 feet, or let me do it for this. Okay, this is my 7 feet from this inside to this inside. Again, from here to here, it is 7 feet, and the depth was 22 inches. So this particular depth will be 22 inches. So in this way, let us consider this is my F1 footing, F2, F3, F4, and so on. So in this way, practically all these footings will be executed on the site. Now you may be wondering, like, how do we understand all these things? So if you are watching my lecture on the Ellison platform, I have my courses. You just have to type Kshay Kamath. You get lot of all these are my different courses where it has been categorized into diploma in building construction, diploma in structural engineering. There are 5 different courses on the same lectures, which is more than around 25 to 26 hours. You can learn everything from there. Else, my courses are also available on Udemy platform. You can even learn from there. Else, I have my YouTube channel by name Civil Brains. You just have to put Civil Brains. A few of my lectures you can get there. Okay, and then I have my own app by name Civil Brains app. It is available on Play Store. You can download that. And if you are interested to buy all these courses and all, you can always contact me on 9953 9047. So since it's an Indian code, you can put +91. Okay, it's an Indian STD code, and 9953779047. This is my WhatsApp number. You can WhatsApp me here so that I can guide you on the Ellison where the exactly the courses are, or even you can buy it from Udemy, or you can take it from an app or anywhere. Okay, so that is how it is. All these things I've explained in a more better way here. Since I have a time constraint, I whatever is required, I'll be explaining you those part, right? Yeah. So this is understood. So in this way, the footing number, the footing type, the footing dimensions will be given. Now coming to the footing reinforcement. Now if you had seen it here, yeah, if you had seen it here, we had provided a lot of reinforcement, isn't it? You can see it here. This was the reinforcement what we had provided. This is a reinforcement what we had provided. So again, what kind of reinforcement you are supposed to provide here? That will be mentioned in the drawing again. So I'll go back to the drawing. So it is mentioned, for example, I'll go with F6 footing now. So the F6 footing, you see it here, what is mentioned in the F6 footing. You have to provide a 12 diameter, T of 12 means 12 diameter bar at 6 inches center to center spacing along the shorter, that is along the X is shorter span, along the Y is a longer span. And again along the longer direction, so you have to provide a 12 diameter bar at 6 inches center to center spacing. Okay, so practically this is how it looks. See, if you had taken my basic course of construction methodology and all, you would have understood all these things. But still, let me quickly try to tell you for someone who has not understood it. So if this is my shorter span, if this is my shorter span, and if this is my longer span, so whatever rebar I've used it here, right? This one in this direction. This is a 12 diameter bar at what was the dimension given? Yeah, 6 inches center to center spacing. Okay, yeah. So it's a 12 diameter bar which has been put here, and the distance between this is 6 inches center to center. So this is 6 inches, this is 6 inches, this is 6 inches, and on. In the same way, in the longer direction also, this is my longer direction. This is my longer direction. So whatever bar I have used in the longer direction, okay, this is also this is also 12 diameter bar, and the distance between these two bar is again 6 inches. So this is again 6 inches center to center spacing. So again, this is 6 inches, 6 inches, 6 inches. Got it? So in this way, the entire mesh will look something like this. So 6 inches, 6 inches, and 6 inches. In the same way, this is 6 inches. This is also 6 inches, 6, 6, and 6. So in this way, the bar bender will arrange all these things, and practically it will be executed. And finally, it is going to look something like this. Got it? Yeah. So I think most of the things I've covered it here regarding the footing. So this is how it looks. And now coming to the excavation part. So this is a typical cross section what they give. Now, how much is the excavation you're supposed to do? It is mentioned here. Right now, you're standing in the ground level. From the ground level to the bottom of your PCC. This is my PCC, which is a 4-inch, comes out to be 100 mm. That was mentioned here. You can see with 100 mm, all footings to be provided with 100 mm thick bed concrete. So this is that particular bed concrete, what you can see. Okay, it is a 4 inches mentioned here. And your depth of excavation will be 5 feet, which comes out to be roughly 1.5 meter. Okay, so this is your depth of excavation. Up to here, 5 feet of excavation will be done. Then the PCC bed will be put, and then the footings are going to come. Got it? Yeah. And this was my natural ground level. And this is the depth of the D is the depth of your foundation, which you're going to get here. For each footing, the depth is different. F1 it is this much, F2 it is this much, F2A it is this much, F3 this is 16 inch, F4 it is 18, F5 it is 20, F6 it is 22, F7 it is 14, and F7 it is 16 inches. Got it? Great. So in this way, you're supposed to understand this, the footing layout. So we'll see the column center line marking here. Okay. So once the footing details is understood, the next is about the column details. Now again, the whatever grid lines you have drawn, right, the same thing will be drawn here. Okay, it remains the same. There won't be any changes. And one more thing, the distance between the grid lines, I'll explain it here. Okay, so how do you do all these things practically on the site? You are going to mark it. Like the distance between the grid line A and B will be 3 feet. B to C will be 7 feet 4.5 inch. C to D will be 3 feet 9 inch. D to E it will be 10 feet 4.5 inch. E to F it will be 12 feet 9 inches. In the same way, we'll start from here also. I can say 1 to 2 it is 5 feet 9 inch. 2 to 3 it is 6 feet 9 inch, 3 to 4 it is 8 feet 6 inches, 4 to 5 it is 13 feet 9 inches, and 5 to 6 it is 13 feet 3 inches, and from here to the outer it is 3 feet 11.5 inch. Okay, now like we had it for the footing, right? In the same way, for the column also we have a name like C1, C2, C3, C4, and so on. Now you see it here. So again, I have a column here. The name of the column is C1. And what is the size of that? It is, yeah, here they haven't mentioned the overall size. Whatever you can see is 4.5 inch. So it is from the center to the left side. Obviously, both the side it will be equal. So it becomes 4.5 plus 4.5 comes out to be 9 inches. And here to here it is 4.5. And from here to here it is 4.5. So it becomes a 9 inch by 9 inch column. If you're not able to understand from here, not an issue. You can again come here. You can see it here. They are given like for the footing they had given, right? In the column also they give like C1, C2, C3, and C4 column. And the size you can see 9 inch by 12 inch, 9 inch by 18 inch, 9 inch by 18 inch, and 9 inch by 9 inch. So right now we were looking for a this particular column. Yeah. Okay. Anyhow, we'll refer here only directly for the column. Okay. Here they have just given us the offset point. Okay, so C1, this is C2, this is my C2 column, again C1 column, C2, 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 C2. So in this way, everywhere wherever you have footing, right, wherever you have footing, there your column is going to come. So how many footings are there? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19. So 19 footings and 19 columns will be there. So again, if I try to count it, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19. Exactly. Now we'll try to understand this particular thing. Okay, so coming to the type of the column, we have only 4 categories: C1, C2, C3, and C4. So C1, C2, C3, and C4. The column sizes are mentioned here, like 9 inch by 12 inch, C2 is 9 inch by 18 inch, C3 is 9 inch by 18 inch, C4 is 9 inch by 9 inch. Okay, now we'll start from here. Now, whenever you do a column, right? So it's my G+1 structure. That is, I have a ground floor, first floor, and a second floor. So below the ground floor also you are going to do the excavation that is called as base. So that is why you can see here, base to the plinth level is 1. From the plinth to the ground floor is my 1. Ground floor to the first floor another level, and first floor to the terrace portion. You're getting my point? So this is how it looks. If I'm doing a column, no? So this is how my column will be. Okay, we'll start from here. So this is my foundation level. I'll do it in this way. Okay, so from my foundation to the plinth will be 1 level. This is my foundation. From here to here, this is my plinth. Okay, from plinth to the ground, this is my level. From ground to the first floor, and first floor to the terrace portion. You got it? So this is how your building will look. It's a foundation level where you have done the excavation. So that is why they have mentioned it in this way. Now coming to this part. This part. Now what is this 12 of 6? 12 of 6 means in this particular column, you're supposed to provide a 12 diameter 6 bar. So 1, 2, 3, 4, 5, 6 bar will be there. In the same way, C2 column, you have to provide a 16 diameter 6 bar. So you can see 1, 2, 3, 4, 5, 6. So it's a 16 diameter 6 bar. In the C3 column, you're supposed to provide a 16 diameter 8 bar. So 1, 2, 3, 4, 5, 6, 7, 8. So if I had taken my earlier this course on the construction methodology and all these things, I've covered it in a more detailed way. Okay, but here we are just trying to see the drawings of one particular building. I hope you are in a position to understand that. If not, you can take my those courses. You can enroll and you can learn from there even in a more better way. So again, here you see you have a 12 diameter 4 bar and 10 diameter 2 bar. Now, how do you identify a 12 diameter and a 10 diameter from here? So it's very simple. Wherever the green color marking is done, no, this is a green. It's a 10 diameter bar. So one green is here. This is my second green. So it's a 10 diameter. And the 12 diameter is like 1, 2, 3, and 4. This is my 12 diameter. Got it? That means outer side 4 bar will be 12 diameter. The inner 2 bar will be my 10 diameter. So in this way, the base to the plinth is done. Now when you come to the plinth, again the same thing will go on. Okay. Again from the plinth to the ground, again it's 12 diameter 6 bar, 12 diameter 6 from ground floor to first floor to terrace. Again you are providing 12 diameter 6 bar. So usually if you're putting a small structure like a ground plus 1, ground plus 2, we don't try to change the steel. Whatever steel we are giving, no, right from the base to the first floor or second floor, we take the same steel. So that is why if you see here everywhere 12 of 6, 12 of 6, 12 of 6, 12 of 6. See here also 16 of 6, 16 of 6, 16 of 6, and then see small changes they have done it here. Instead of 16 of 6 in the ground floor to first floor, you are providing a 16 diameter 6 bar. When I come into the first floor to the terrace, what they have done, they have not done 16 of 6. Instead of that, they have given a 16 diameter 4 bar, and the rest 2 bar they have made it of 12 diameter. Why is that so? Because when you're coming to the terrace portion, your load is very less. When the load is very less coming on the column, the steel requirement is also less. So instead of using a same diameter of instead of 16 of 6, we have reduced that from 16 of 4 to 12 of 2. Okay, will not reduce the number of bar. Diameter of a bar can be reduced. Like see, 6 bars are there, and here also 4 plus 2 is 6. So we'll not reduce the diameter, will not reduce the number of bar. Instead, we'll reduce the diameter. That can be done. Similarly, you see here, you are providing a 16 diameter 8, 16 diameter 8, 16 diameter 8. But here you see 16 diameter 4 and 12 diameter 4. 4 plus 4 is 8. Here also 8. But only the thing is, instead of 16 of 8 number, we are providing a 16 dia 4 and 12 diameter 4. Got it? And same thing here also. Here anyhow, we have kept it very similar. 12 of 4 and 10 of 2. 12 of 4 and 10 of 2. 12 of 4 and 10 of 2. And here also 12 of 4 and 10 of 2. Got it? So this is how you are supposed to understand the column details. And to put it in a better way, I can quickly show you one of the drawing for the columns. Yeah. So this is how your column looks. Can you see a column here? This is that column. For example, if I say a 16 diameter 4 bar, this will be 1. This is a 1. Then another bar we have 2. Okay. Behind this we have another one 3. Behind this we have another 4. So let us say it's a 16 diameter 4 bar. So in the same way, if I take one more drawing, here if you see, if you observe here a lot of reinforcements are there. Okay, it depends what is written in your structural drawing. Now you observe here also you can see a lot of drawings, a lot of reinforcement. 1, 2, 3, 4, 5, 6, 7, 8 are there. Let us say 16 diameter 8 bar. So all these are the 16 diameter 8 numbers are there. Got it? Similarly, if I come here, yeah, again you can see here, yeah, you can count it here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 bars are here. Okay, so in this way you're supposed to do all again you can see it here also, no? Yeah, here also see here a lot of reinforcement has been done here, isn't it? It all depends what is there in a structural drawing. Based on that, we try to do all these things. Again, like I mentioned, these things are there in all of my courses. You can learn from there also. Okay, yeah, great. Now the last part, what is left out, that is about the lateral ties. So we'll see the lateral ties. Now, if you had observed, they have written something here, right? 2L 8 at 175. That means you're supposed to provide a 2-leg stirrup or a 2-leg lateral ties, and the spacing should be 175 center to center. That means, to put it in a better way, directly we'll see here. You can see the lateral ties here. Can you see a lateral ties here? This rings, whatever you can see, isn't it? So this is the rings you are supposed to provide. Okay, this is first ring, let us say. This is another ring. Okay, so these rings are made up of 8 diameter bar, and the distance between the two things, it has to be 175 center to center spacing. Got it? So that was there in my drawing. So similar to that I'm going to do. Yeah, you can see it here. You get a better picture. So the distance between these two lateral ties, this everywhere, it is 175, 175, 175. How it is 175? Based on this particular drawing. Okay, or for a C1 column. In the C2 column also it is same, C3 also it is same, C4 it is also same. So everywhere in this particular building, you're supposed to use a 2-leg stirrup. Why it is called as 2-leg? Again, the reason remains very simple, because this is how your lateral ties look. Okay, so this is my one leg, this is my one leg, this is my second leg, so it's called as 2-leg. Along with that, if I provide another 2, something like this, then it becomes my 4-leg. Why is it 4-leg? So 1 and 2, 3 and 4, it becomes a 4-leg. But here it is 2-leg. Instead of 2-leg, if they had given 4 here, I'll make this as 4-leg. Wait, yeah. So if they write 4-leg here, it's understood. Along with that, they would have made something like this. Okay, then this would have been your 4-leg stirrup. Getting my point? Usually in the column, 2-leg, 4-leg comes into play. So if you want, I'll show you a live image of that. So here it is a simple one. Yeah. We'll Yeah. everywhere it is a single one, what we can see. Yeah, maybe in the next one I'll show you. Yeah, so here you can get an idea. Yeah, something like this. Can you see? This is my this is my sixth leg. So this is one. Okay. Then the center one is another one, two leg, and this is another two. Two plus two plus two comes out to be six leg. Getting my point? Yeah, you can see it practically. So this is how it is given. This becomes my four leg. So why four leg? Again for the very same reason. This is my first one, which goes like this. First one, which goes like this. Okay, it's a two leg, and after that I'm putting another one. This is another one over that. Okay, got it? So this is called as four leg. Same thing, you can see it here also. So this becomes my sixth leg now. So this is one, this is second one, and then this is my third one. Got it? Chalo. Fine. I hope your concepts are clear, and you have understood how to understand the column layout and the column drawings. So in the next lecture, we'll be taking up the plinth beam shuttering layout and the ground floor roof shuttering layout, and then the beam details, and finally we'll see the slab details. How the plinth beam layout has given, and also we'll try to see the details regarding that. Okay. So to put it in a better way, let me quickly show you how a plinth beam looks. You know that if someone who is new, let me show that, right? No harm in showing that. So if you see this, no, I'll go here. So if you remember, once we do the excavation and all, no, we do a backfilling. Okay. So once the backfilling will be done, we try to put this PCC, and after the PCC, we do a shuttering. Okay. This is a shuttering, what we call. Okay. You can see this is your PCC you put. This is your plinth beam reinforcement, which we'll see later. Okay. And then you put a shuttering, something like this. And after that, you do the concreting of this, right? Now, what is this particular beam? What is this particular beam? Like, to put it in even in a better way, I'll go with this. Yeah. So these are my plinth beam. If I try to take out all these things, yeah, yeah. So all these are my plinth beam. Okay. Now we call this as PB1. We call this as PB2. We call this as PB3, PB4, PB5, PB6, and so on. Got it? Okay. Yeah. This is how the plinth beam is all about. Now, what is the width of this? What is the depth of this? That I don't know. For that, what I'm supposed to do, I need to go back to the drawing. What it is written here? Plinth beam shuttering details. Okay. That means what is the shuttering you're supposed to put, that is given here. Now we'll try to see here. Okay. So you can see the same thing here. Whatever columns we had, no, for the same thing, we have done the plinth beam layout. Now, the main intention of doing the plinth beam is that how do you connect a plinth beam from column to column? For example, even before doing it here, no, I'll make you to do the same plinth beam layout. So the main intention will be to connect the column to column. Can you do this? So yeah. So quickly we'll try to do this. Okay. You also have to participate along with me. So see, my main intention is to connect the column to column. I have one column here. This is my second column. Can I connect a beam something like this? Obviously I can do. Can I connect a beam something like this? Obviously I can do. Can I connect something like this? Of course you can do that. Now I'll go horizontal only. I'll come to the vertical part later. This also I can connect. This also I can connect. This also I can connect. Agree? So this is a plinth beam. Now, the main rule is that always whenever you are doing a plinth beam, the main idea behind that is you have to tie the column in at least two direction. So what I'm trying to tell, for example, let us say if this is my column, okay. So this column is tied in two direction. No, because this beam is only tied in this direction. I have a space either to tie it here or to tie it here or tie it here. Anyhow, I don't have anything here. So what I'll do, I'll try to tie it in this direction. Okay. So can I connect a plinth beam here? Of course I can do that. Okay. Okay. Next, for this column, can I connect in this way? Of course I can do that. Okay. For this column, can I do? Of course I can do that. For this, of course I can do that. Okay. Got it. Now, is it necessary for you to connect this column in this direction? Plinth beam, not at all required. Why? Because you don't have anything here. Just in case if there was one more column, then you could have connected that. Now, my intention or my idea of saying that one column should be connected in two directions. Can you see that practically it has happened? So if I say, if I take all the column, if this column, if I consider, is it connected in two direction? Of course, it is connected with this pink color or a magenta color beam in this direction and the white color in this direction. Suppose if I take this particular column, C2 column, in how many direction it is tied? It is tied in this direction, and in this direction. So minimum is 2. You can connect that in 4 direction. Okay. But minimum 2 I have done here, and here I have done. Here also 1, 2, 3. Here also 1 and 2. Got it? In this way, everywhere I need to connect. And then I'm going to name it like, let us say if this is PB1. Okay. Next, I'll say PB2, that is plinth beam 2. Then I'll say PB3, that is plinth beam 3. I'll go horizontally. Again, there is a method to that. It's not that randomly you're going to put. We'll go with horizontal from left to right. So left to right, I went PB3. Next, I'll come here. PB4, I'll say PB5. Okay. And then I'll say PB6. Got it? I'll say PB6. Now I'll go vertical. Horizontal is done. Vertical, I'll start from bottom to top. So now bottom is this is top, right? I'll give this another name. I'll give a different name to that. Let me call this as PB7 exactly. PB7. This is my PB8, and this is my PB9, and finally, yes, now we are done with this PB10. Got it? So this is how the structural detailing is done. But I've given you a basic idea how it has to be done. Now with this concept, we'll try to see whether the same thing has been applied here or not. So this is usually what we do. Sometimes they may apply, sometimes they may not apply. Let me try to check out. Okay, now you see, I had a column here. It has been connected and they have given a name exactly PB1. They've given a name to this PB2, PB3, then exactly PB4, PB5, PB6, come here. PB7, PB8, PB9, PB10, 11 and 12. Got it? Next, again, we'll go from bottom to top. This is what I follow. Few people follow from top to bottom. Anything is okay. It depends on you. Okay. So, yeah, what these people have done, we'll see that from where the PB12 got ended here. So, where is my PB13? Yeah, here started from here. Good. So, this is PB13. This is PB14. This is PB15. And then, exactly, this is my PB16. Got it? PB17. And then 18, 19, 20, 21, 22 and 23. Done and dusted. Very simple. So this is how the plinth beam layout has to be understood. And practically when you do the execution, no, this is how your beams look. Let us say if this is my PB1, PB2, PB3, PB4, PB5 and so on. Very simple. Okay. If you are still not understood how these things has to be done, again I repeat it again and again. All these things has been explained in my construction methodology course, where all this has been dealt in for more than 42 hours with a step-by-step procedure. Okay, good. Now, once this is done, next what we do, this is the size of that. Like PB1, the size is 9 inch by 15 inch. So 9 inch is a width and 15 inch is your depth. To put it in a better way, so this is my 9 inch. So this is my 9 inch breadth. This is my 9 inch, the breadth, and the depth is 15 inches. Got it? So in this way, what they have given us the size for all the beams. So now you can identify by looking at this. Can you do the execution on the side? And can you read the structural drawing? It's very simple. You can read it now. Yeah, great. Got it? Yeah. Now, one more thing. PB1, the size is 9 inch by 15 inch. I agree to that. But what is the reinforcement you're supposed to use? Reinforcement in the sense, so you can see all the reinforcement has been put up here. So if you see here, this guy was arranging the reinforcement, isn't it? Where was that guy? Yeah. You can see all the reinforcement kept here. They kept 2 rebar at the top, 2 rebar in the bottom. How do you take care of that? From where it is written? So for that, you need to refer the plinth beam reinforcement details. So right now I was showing you plinth beam shuttering layout or shuttering details. Now I'll go to the plinth beam reinforcement details. Now what is written here? Yeah, they have written plinth beam shuttering. It's not shuttering, okay? It should have been reinforcement. Sometimes error will happen. But as an engineer, we should know what is wrong and what is correct. Okay, yeah, plinth beam reinforcement. Okay, reinforcement details done. Now I'll go with PB1. This is my PB1. I'll see what is the reinforcement I'm supposed to provide. So for PB1, I'll go to this drawing, and this is my PB1. Agree? So you can see this is my PB1. Okay, and this is my 2 columns. Now what is this? You can see this white color. This is 1 column. This is my 2nd column. That means it is in between these 2. This is 1 column and this is a 2nd column. In between this you have this PB1. So same thing they have shown it here. You just have to concentrate on this part, which I'm going to explain now. Yeah. Just concentrate on this part. That is enough. Only this much part. Okay, good. So this is PB1, size is 9 inch by 15 inch. Now they have given you the reinforcement. What is mentioned? 12 of 2. That means you have to provide a 12 diameter 2 bar at the top. So top 1 and 2 will be my 12 diameter 2 bar, which will go completely. That is from this column to this column. From this column to this column, your 12 diameter 2 bar will come. 1 and 2. Simple. Now come to the bottom portion. So bottom, what is shown? Bottom, they have shown 12 diameter 3 bar. 3 hash of 12 means 12 stand for 12 diameter bar. 3 is the number of bar. That means in the bottom, you are supposed to provide a 12 diameter 3 bar. So practically how it looks, we'll see that. So it is 12 diameter. Yeah. So practically it will be something like this. 12 diameter 2 bar in the top. This is one. And this is my second bar. This is at the top. And in the bottom, it's a 12 diameter 3 bar, right? So I'll draw a 12 diameter 3 bar in the bottom. So let us in the bottom 1, 2, and 3. Got it? So in this way, you're supposed to do. Now you tell me what was the reinforcement written here. You can see 3 bars, isn't it? 1, 2, and 3. So 3 in the top, and in one in the bottom also there is 3. I'll take this as 1. There's one more here and one more in the side. So 3. Now you got it. So in the drawing, if it is written 12 of 3 at the top, 12 of 3 in the bottom, you're supposed to practice that. If it is written 12 of 2 in the top and 12 of 3 in the bottom, at top will provide 2 bar and the bottom will provide 3 bar. Done? Very simple. Now, sometimes it will not end here. Sometimes there is something called as extra reinforcement and all. Okay. So what is that extra reinforcement? We'll see now. Yeah. So now you can see along with that, these people have mentioned something. If you see here, there is one bar which is coming from here. Agree with me? And it is taking a bend in this way, and it is coming here, and it has been stopped here. And now they have mentioned that this particular rebar, what we are seeing right now, it's a 12 diameter one bar. That means already I have provided 12 diameter two bar top completely. Along with that, it is showing me that you have to provide another 12 diameter one bar. Okay. So that means practically what will happen here, the negative bending moment will be more. Because of that, more moment will come. Because of that, more steel is required. So this bar is again needed. So practically how this will look now, I'll show you. So yeah, so let me draw a small view for you. I'm drawing a front view. Okay. So first 12 diameter 2 bar. This is 12 diameter 2 bar at the top. Along with that, you'll provide another 12 diameter 1 bar. This is another 12 diameter 1 bar in the center, but this will not go completely. It will stop only up to here. Okay. So that is why they have shown it only up to here. And what is the distance that is mentioned? 3 feet 4 inch. That means this particular bar will go only up to 3 feet 4 inch. So practically, I'll show you one more image, but that may not be for the same beam. Yeah, exactly. Now you got, see, now you'll get a complete idea. Okay. This is pretty good. See here how it has happened. Yeah. So this is your 12 diameter 1 bar, which will go completely. And this is the another 12 diameter 1 bar, which will go completely. Another 12 diameter 1 bar I'm supposed to put, but not completely. It will go up to 3 feet 4 inch. So that means I'll show here. Can you see one more bar which is at the center, which has been stopped here? Exactly. So this is your 12 diameter 1 more bar, but it is stopped at the 3 feet 4 inch distance. Very simple. Yeah, great. So this is how you are supposed to understand the drawings. So similarly in the bottom, I don't have. In bottom already I have provided 12 diameter 3 bar. Got it? Now coming to the main important part. What is this 8T at 7 inches center to center spacing? 8T at 7 inches center to center spacing? 8T at 7 inches center to center spacing? It means you are supposed to provide a stirrup, and stirrup will take care of the shear force. Actually, stirrup will not take off shear force. The shear force will be first taken by the this bar, your bottom longitudinal bar. It will take care of your shear, and the aggregate and the concrete, whatever interlocking we have, that also will take care of your shear force. In spite of that, again, if there is excess shear force, that will be taken care by the stirrup. That's the logic behind that. Okay. So 8T in the sense you have to provide a 8 diameter bar at 7 inches center to center spacing. That means if you see it here, if I go back to this, can you see a lot of stirrup has been placed here? Can you see this kind of stirrup which has been placed? See, this is called a stirrup. In beam, we call it as stirrup. In column, exactly, we call it as a lateral ties. So this stirrup what diameter you're supposed to use? You're supposed to use a 8 diameter bar. I agree with that. And what is the center to center spacing you're supposed to keep? So this center to center spacing, you're supposed to keep how much? It is mentioned in the drawing, that is 7 inches center to center spacing. 7 inches comes out to be 175 mm, because 1 inch is 25 mm. So 25 into 7 comes out to be 175 mm. So this spacing, whatever you have to maintain, no, it will be 175. Okay. So this spacing will be 175 center to center spacing, or 7 inches. So from where did I say all these things? Again, it was mentioned in the drawing. I'll go back to the drawing. You can see 8 is stand for 8 diameter bar at 7 inches center to center spacing, center to center spacing, and center to center spacing. Now, why is that? They have shown it here. They have shown it in the center. They have shown it at the right side, because that is a typical way how the beams are designed. So if I go back to this again, so whenever we design a beam, or if I show it here, yeah, I'll take this beam. Okay, I'll consider this beam. So in this beam, we have three parts. One is my left support, one is my right support, and then the center portion. So if I cut it down, this is my left support, let us consider. This is my right support, let us consider. And whatever is at the center, that is my center. Okay. So they are telling us now, in this particular case, what has happened? In this particular case, this is my left support, agree. This is my right support, and this is my center. Okay. So they are telling that you have to provide 8 diameter bar at 7 inches center to center spacing in the left support, 8 diameter bar, 7 inches center to center spacing in the right support, and also in the middle it is same. So when entire span it is same, why did they mention it 3 times? So basically that doesn't happen all the time. If I show you some other drawing, that spacing will vary. In the left and the right support, it remains the same. In the center, we usually increase the spacing. So I think in this drawing, everywhere the spacing remains the same. So that is a pattern what they follow. But if I show you for the roof part, you may find a difference. Let me see some way if I can find. Uh, no, I cannot find, but that is a typical trend. So let me make one beam for your understanding. Let us say, so instead of this 7, no, I'll make this as 11 inches. Okay. Now can you spot the difference? So this and left and right support will always be same. Only the center we are going to increase the spacing. So why we are going to increase the spacing? Why is that? We'll try to see in the next lecture. Till now, you have understood the concept, that how the stirrups has to be understood, how the reinforcement has to be understood. I explained you for one beam. The rest, whatever beam you are going to see from here onwards, no, it remains the same. But if you want to learn even in a more detailed way, then of course, like I mentioned, there's a course of mine on construction methodology where I've explained you. Else, there's a drawing reading course of mine. On the drawing reading course, you can learn all these things in a more detailed way. For almost 20-25 hours of the content, I've explained everything of all these things. Okay, that is even in more detailed way. You can always contact me on this 9953-7790-9047. This is my WhatsApp number. You can always WhatsApp so that you can have access to my course. Okay. Yeah. Yeah. 9953-7790. This is my WhatsApp number. And you can add a +91 for the Indian code. Add +91. That is the Indian code for India, and 99527790 for this WhatsApp. So there, I mean, I can refer you some courses of mine where you can learn all these things in a more detailed way. Great. Yeah. So I think with this, we'll end this lecture. So I hope you have got an idea how to understand this particular thing. And sometime you'll be having the extra bar, whatever bar we saw it here, right? This time we had only on the left side. On the right side, we don't have. But if you observe this PB4, can you quickly spot me the difference in this PB4? So just this is my PB4, okay? Concentrate on PB4. Yeah. What is written? They have written 12 diameter 1 bar, 12 diameter 1 bar. Yeah. Where is my main bar? That main bar they have not shown, I guess. Yeah. So this is actually your 12 diameter bar, okay? This is also your 12 diameter bar. Bottom, you see, you have to provide a 12 diameter 3 bar. This is actually a 12 diameter 3 bar. I think they have missed out. They haven't shown it, okay? This is also 12 diameter 2 bar, and plus one extra bar will come. Okay, I'll do it in this way. Yeah, yeah. So this, I'll make this as 2. Okay, now you can understand. So it is written how much? So it's a 12 diameter 2 bar. Okay, I'll take it to the top now. Yeah. So this is 12 diameter 2 bar. This is the 12 diameter 2 bar, and then 12 diameter 1 bar, but that is only in the left support up to here. Left. At what, till what distance? It is 3 feet 1 inch. Similarly, on the right side also you have to provide another 12 diameter 1 bar, which will go up to 3 feet 1 inch. And bottom you have to provide 12 diameter 3 bar, 1, 2, and 3. Spacing everywhere it is 8 diameter bar, 7 inches center to center spacing, 7 inches and 7 inches for the stirrup. Very simple. So in this way you are supposed to do the execution on the side, and that's how we do the execution on the side. So we'll see how the ground beam shuttering and also the reinforcement is worked out. It's very simple. Okay. Now we did with the plinth beam, right? Once the plinth beam is done, next you can see here, this is my ground beam. So this was my plinth beam. Okay. So after that, I am going to raise my column again, and I'm going to put a beam here. Now this becomes my ground floor, and over that, if you put again, it's first floor, second floor, and all. Right now we are looking at the ground floor beam reinforcement details or ground floor shuttering layout. So hence it is written here ground floor roof beam shuttering details. It's very similar to this. Okay, there's no changes. Instead of P, we write here G, that is a ground GB1, then GB2, GB3. So in this way, wherever beams are going to come, you're going to connect that everywhere. Okay, very simple. Now you can understand all these things. GB1, GB2, 3, 4, 5, 6, 7, 8, 9. Then we have 10, 11, 12. We have 13, 14. Yeah, we have 13 here. Then 14 start from here, 15, 16, and so on. Now coming to the reinforcement details, again it's very simple. If I look for GB5, I'll look for GB5. GB5 is 9 inch by 18 inch. Let me look into the reinforcement of that. So for that I need to refer this one, that is ground beam shuttering details. It is not shuttering again, it has to be reinforcement. There's a mistake here. I'll go for GB5. So my GB5 will be somewhere here. Yeah, this is my GB5. So you can see this is my GB4 beam. This column to this column, whatever beam I'm getting, it is GB5. And from this column to this column, whatever beam I'm getting, it is my GB6. Great. So let me look into the GB5 reinforcement details. No, let me go with GB6. This is pretty interesting. So if I go with the GB6, just concentrate on GB6 and it's good. Yeah. So for the GB6, everything you know now. So what is written here? This particular reinforcement. So I don't know what exactly is this reinforcement, right? This 16 diameter 1 bar is my top left extra. 12 diameter 1 bar is my top right extra. But this middle bar, it's not mentioned. Since it's going throughout, everywhere it is same. So it is actually your, it's written here. See, sometime it won't be written here, okay? They're not mentioned. So then you come back, you'll see here what is there in GB5. So in GB5, you are providing a 12 diameter 1 bar at the top. So that means the same bar is continuing in GB6 also. So they are not mentioned. Else, let me copy this from here and let me paste it here. Good. Okay. Yeah. Not done. Where is that? Okay, it is here. Okay, it will come there. No issues. So it is written here. Okay. 12 diameter 2 bar. This is your top bar. Will provide 12 diameter bar throughout. Left extra will be a 16 diameter 1 bar. And it will go up to how much? It will go up to 3 feet 11 inch. And your top right extra will be 12 diameter 1 bar. It will go up to 3 feet 11 inch. Now you come to the bottom portion. So bottom is bit interesting. In the bottom, what is the bar you're supposed to provide? It is not mentioned again. Again, you come here. In bottom, they'll write it here. You can see here. This is 16 diameter 2 bar in the bottom, which will go throughout for all the beam GB4, GB5, and GB6. Hence, you cannot see that. So whatever you are seeing this 12 diameter 1 bar, no, that is an extra bar. That is called as curtailment bar. I'll explain you what is that curtailment bar. Now you understood. Your bottom, you are providing a 12 diameter 2 bar. Along with that, you'll provide one more 12 diameter 1 bar. But that second bar will not go completely. It will just stand up to here. So this second bar, whatever you are providing, no, it will be only up to here. It will be only up to here. Whereas already you have provided, if I do only for already this already there is 12 diameter 2 bar, 1 and 2. In between that, you will provide one more bar. So that will stop only up to this distance. So then what distance it is stop, it is shown here. From here, from the outer face of the column, you are leaving 1 feet 3 inch this side. And from this outer face of the column to here, you are leaving 1 feet 3 inch distance. And whatever distance you have, that will be a bottom curtailment bar. Got it? Now, what is the reason behind all these things? We have already understood. But quickly, let me tell you that. The simple logic is that about the bending moment. So here we'll be having a negative bending moment. Here we'll be having a positive, a negative, and something like this. Since we are having negative bending moment, your beam part will try to lift up. So we require more reinforcement. Here also we have negative bending moment. So my beam part will try to lift up. So I'm providing more reinforcement at the top and more reinforcement at the top. Whereas in the bottom portion, we have this positive bending moment, that is sagging bending moment. The beam is trying to sag. So that is why I provided more reinforcement in the bottom. So that is why this bar has been curtailed here, because after this, I don't have any sagging bending moment. It's completely a negative here. So that is why what we did, we took our bar only up to this distance, not completely. You could have taken completely, but you are actually making a structure uneconomical, which is not actually required. So that is why this is a typical behavior. So that is why how the reinforcement have worked out. Very simple. And then your stirrup is very simple. 8 diameter 7 inches, 8 diameter 7 inches, 8 diameter 7 inches. Very good. Done. Now, this was all about your ground beam reinforcement details. Now I'll go to the slab part. Now again, this is my ground floor roof shuttering and reinforcement details. Now, how do you understand the reinforcement? So first, this is my entire slab layout. Okay. So this is how my slab is going to look. So each slab, they have given a thickness of my slab. So the thickness of my slab is 5 inch. The thickness, like beam, we have 9 inch by 15 inch. So slab will give only the thickness of the slab, which is again 5 inches here. So here also it is 5 inch, 5 inch, 5 inch. So everywhere you can see, everywhere it is 5 inch. So only here it is 6 inch. Rest everywhere it is a 5 inch, 5 inch, 5 inch, and this is also 6 inch. So you understood the thickness. Now coming to the reinforcement. So this is how the reinforcement looks for you. So how the reinforcement looks, you don't get an idea here. I'll show you through a practical image now. So this is a typical beam reinforcement what we get. So what we do, we try to provide the crank bar. Now what is crank bar and all explained in my construction methodology course. I'll take one bar from here, okay, and then I'll do it here. I'll take one bar from here. I'll give a crank. I'll take it here. I'll give a crank. I'll take it here. Okay, you got it. Then again, I brought one more bar, gave crank, took it here, gave crank, took it here. Okay, and now I'll take another bar from this side, brought it, gave a crank, took it like this, and then gave a crank, took it like this. So this is my two-way slab. So this is how my reinforcement will look. So whatever reinforcement you're seeing, no, so practically those things are given here. Now you got an idea. Now if I try to draw the same thing here, you will get an idea. So that is, we'll start from here. You brought a bar here, you gave a crank, and you took to the top. Okay. Next, you brought a bar from here, you gave a crank, you took here. So there are different ways of giving a bar. Right now, I taught you both the side crank. This is also crank. This is also crank. Sometimes what we do, we give crank in only one side and we take, and then we give crank from other side and we bring in this way. So it all depends how the structure consultant has given that. Here what he has given is, he has given a straight bar, a crank and a top will go. Then from here you will get the same bar, you'll give a crank and you'll bring it here. Very simple. Similarly on the other side also you have done the same thing. See here, you have brought a crank, bent it here, took it like this. Okay, and the next bar you are taking it straight, you will give a crank here and you will take it here. This is my continuous support, right? So this will become my top reinforcement for this slab also. Okay, this becomes my top reinforcement for this slab also. Got it? So in this way you are supposed to understand the slab reinforcement. Slab reinforcement will take a bit time. And now coming to the reinforcement details, what diameter you are supposed to use, it is mentioned. That is this bar and this bar, the distance what you are supposed to provide is, you have to provide a 8 diameter bar, and the distance between this and this bar is 7 inches center to center spacing. Similarly, this bar and this bar, what is the distance given? It is mentioned here. Where it is mentioned? Yeah, I think, yeah, it is mentioned here. Can you see? In this direction, this two bar, whatever they have given, you have to provide a 10 diameter bar at 7 inches center to center spacing. So always the bars will be placed in the shorter span first, followed by the longer span. So this is my shorter span and this is my longer span. So in the shorter span, you're supposed to provide a 10 diameter bar at 7 inches center to center, and longer direction will be your 8 diameter bar at 7 inches center to center spacing. Got it? Rest other things remains the same. It's very simple. Whatever I explained you here, right? Same thing they have given it here. Same thing they have given it here. Okay. And what is your that top extra bar and all? Like for example, yeah, what is your curtailment length? What is this length and all? This length, okay, the crank length from here to here, what is a crank length? From here to here, what is a crank length? Okay, all those things it is mentioned in the drawing. If you just observe it here, can you see the difference here? See, they have given that from here, from the outer of the beam, you have to keep 3 feet 3 inch. Okay, from this outer of the beam to this, it will be 2 feet 5 inch. Got it? So in this way, again from this outer to this part, your crank will be 1 feet 8 inch, and from here to the this part, it will be 3 feet 3 inch. Again from here to here it is 2 feet 5 inch. Got it? So in this way, you're supposed to understand the drawing, and based on that, the entire execution will be done on the site. Very simple. Yeah. So this is all about the slab part. I hope you have understood this concept. Slab will take some time. If you have understood, it's well and good. Else not, when you start to practice on the site, you will be able to understand. Try to understand the basic thing, that is the thickness we are supposed to understand. The reinforcement details will be given here, like you have to provide a 10 diameter bar at 6 inches center to center spacing, and this will be your 10 diameter at 6 inches center to center spacing. And the way you are supposed to provide, I have shown you that through a practical drawing. Okay. I hope this much is understood to you, and we have understood how the slab reinforcement is to be given. And here you'll get certain details, like if something is shown in dotted point, in dotted way, it is a top reinforcement. If something is shown in the straight line, it is bottom reinforcement. For example, if I come here, see why it is dotted, because it is top reinforcement. That means practically that will go to the top, isn't it? So you can see this is my top reinforcement, this is coming in the bottom. So whatever is there in the bottom, that is shown through a straight line. So this is my bottom, isn't it? It is shown through a straight line. So this is my which portion? Top portion. Got it? Yeah. We'll see how the staircase reinforcement and also the layout for this staircase will be done. Okay. So you can see a kind of a staircase here, right? So the same thing will be mentioned in the drawing also. Quickly we'll see that. See? So this is your first flight. We call this as a flight. And this is my second flight. Like this is my first flight. Then comes your landing part. And this is your second flight. So your landing part will look something like this. This is my landing part, which is just 3 feet 3 inch. So practically this will be from here to here, it will be 3 feet 3 inch. Okay. And now this is called as rise. So this part is called as rise, and this part is called as thread. So practically, I mean, in the drawing, it will be written. You can see rise. Rise, they have mentioned 6 feet 5 inch, 6 feet 5 inch. So this part, okay, this part, this height, or it is written here, right? 6 feet 5 inch, and this thread. So this is a thread where you keep your foot. So that is a 10 inches. What is mentioned? How many steps are there? It is given 1, 2, 3, 4. It will start from here. 13th is your landing slab, and 14th is again your next step. It will go up to here. So this entire is one floor. This is floor to floor distance. Top of this floor, from bottom of this floor to the top of this floor, it is a 10 feet height. This much is clear. And of course, this is your plinth beam, and over the this is your laterite wall. Over that you put a plinth beam, and then and beside that your staircase will come. Got it? Yeah. So this was the entire elevation of that, I mean the section of that, and then this is a plan of that. So this is how your plan looks. So you'll start your staircase 1, in a sense it's the first step, 1, 2, 3, you'll go up to 12. So this much is your 13, this entire part is your landing slab, which is again 3 feet 3 inch, which is mentioned here, 3 feet 3 inch. So this is at 3 feet 3 inch, and then 14, 15 up to 25, this is your first floor level. Got it? And your thread, this is 10 inches, and riser, of course it is not seen in the plan, it will be seen in the section only, cross section. Got it? This much is clear. Now coming to the reinforcement part. So your reinforcement will be something like this. This is my first flight, isn't it? So my reinforcement will be something like this. So what they have done, you cannot directly put your staircase. You have to either rest it on the beam, or you have to give a separate foundation. Here they have not given a beam, like it is not coming on the plinth beam. So what they have given one foundation only for this particular staircase. You can see the PCC. Over the PCC, a footing is done, and then yours this thing, that is a column. This particular thing will start from here. Okay, got it? Yeah. So this is how the reinforcement is given. Your main reinforcement is this one. So this will be your main reinforcement. I'll show it for you. This part. This part is your main reinforcement, which is going in this way. And which diameter of a bar you're supposed to use? You're supposed to use a 10 diameter bar at 4 inches center to center spacing. And the dotted one, the blue color, whatever you can see, they are your distribution steel. That is a 8 diameter bar at 7 inches center to center spacing. So 7 inches center to center spacing you're supposed to provide. Got it? So this is how your reinforcement is to be given. And then you'll be having certain extra bars and all here. So this is your extra bar, what you can see. Okay, this is extra bar, and this is also your extra bar. So how much it is? Again, it has to be 3 feet from here. This will be again 3 feet from here. Got it? So in this way, all the distance will be mentioned to you. Based on that, you are going to do the execution. So to put it in a better way, if I show you, I may show you one picture. See, this is how it looks. Okay, so this is your first flight. This is how you arrange your reinforcement. So according to our drawing, this is my main reinforcement, which is a 10 diameter bar. And what was the spacing given? So it's a 10 diameter at 4 inches and 8 diameter at 7 inches. No, 47. Yeah. Yeah. So this is my main reinforcement, which is 10 diameter at 4 inches center to center spacing. All these things. Okay. And I'll put my distribution steel also. This is my distribution steel, which is made up of 8 diameter bar, and the center to center spacing is 7 inches. Okay, got it. So in this way, you're supposed to do the reinforcement work, and this is a landing level. And now you can see the extra bar here. Like, where is that extra bar which has come? Yeah. So this is your extra bar. Okay, and this will go only up to 3 feet 3 inch. Bottom also there is one bar. This is your extra bar which will come. Similarly, on the top side, can you see that extra? Okay, I'll draw it for this completely. Yeah, and for the top, I'll do it again. This is your top extra. Okay, from the top, this extra you can see till what distance it will go. It will go up to 3 feet 3 inch. So this is your top extra. Okay, now practically we'll see. I mean, through a drawing, if I show you that. So can you see this part? It is written not 3 feet. Yeah, this is 3 feet. This is the extra bar which is coming from the bottom, and top this bar. Okay, this top I'll show you. This top also, it is how much? From here to here it is 3 feet. This is that your top bar. So practically this is how it looks. So this is your 3 feet, and this is also 3 feet. Very simple. So this is how you're supposed to understand the reinforcement for the staircase, and those things I've covered it here. Okay. Uh, Rest, I've explained it for one flight. Similarly, this is for the second flight again. Again, this is your landing slab. So in the landing slab, what reinforcement you're supposed to give? Again, it is same. That your distribution will be 8 diameter at 7 inches center to center spacing. And again, the same thing will go. Okay. Bar remains same only. 10 diameter is your main bar. 8 diameter at 7 inches is your distribution steel. That extra will be 3 feet, and this extra will be 3 feet. Practically, this is how you're supposed to do. Yeah. So again, this is a landing part, and you're going to do that. Very simple. Yeah. So along with this, we'll try to see a few other things also here. So the staircase part is done. It's simple. So here they are mentioned about the compound gate also. Like, see, this is how your compound gate will come. Okay. Sometimes people do that. So this is a compound gate, and you're going to give a slab here. Okay. And then these are the two columns. And this is a name board what will come, and a kind of a design like this. So here they are given a bit detailing about that, how it looks and all. See, this is your compound wall. This is the compound wall detail. This is a gate which is almost 5 feet height. Your gate. The top of your column will be 8 feet 6 inches. Then a 6-inch beam will come, something like a kind of a slab. Okay, that a cantilever slab will come so that it looks good. It's a 9-inch column on both the side. This is another small gate which will come. This can be utilized for the vehicles, bigger vehicles. For scooter and all, you can make use of this. Then the name will come, who is the owner of that house, and your compound wall will look 1 2 3. This opening we are going to do on the compound wall, and all this first, I mean, tiles or whatever pieces or granite pieces you can put it here, and you can give a good elevation to that. Okay, so in this way they have given the complete details. Now coming to the gate part. So this is how your front, you call that as pergola details. Okay, so this particular thing, details whatever you do, no, it's called as pergola details. So this is your left side parapet details, how it looks, your entire compound wall and all. This is the right side details, how it looks. Okay, so those things they have mentioned it here. So in this way we get an idea how we have to how we are supposed to do the compound wall and all. Okay, yeah. So great. I hope this remains the same. Whatever was there, the same thing they have shown it here. No problem. Okay. Yeah. So I hope I was able to explain you most of the things through this entire series of lectures. We started with the plan, and we understood everything. We understood about the plan, the footing layout, the column layout, plinth beam reinforcement, ground floor layout, ground floor reinforcement details, slab details. We understood the staircase and also the compound wall, right? So this was all about this complete building, and I hope you have got an idea at least how to read a drawing for any of the building if it is given to you now from here onwards. So almost all the drawings will look similar to this. There won't be much difference. Slight changes may come, but the way of understanding remains the same, like I've explained it for you. So we'll see you in the next lecture. Thank you.